Hello, welcome to our first assignment. In this assignment, we're going to be doing the scientific method. And I've seen this quote on the internet for years now. Remember, the difference between science and messing around is writing it down. So of course, we're going to write it down. Now here are 4 famous scientists that I selected. This first one is Charles Darwin. He went to theology school. He was in Natural History Club. His father wanted him to be a doctor. He wanted to be a priest, so his doctor sent him on the Beagle, and he basically noticed evolutionary change in the Galapagos. This is Dr. Tyrone Hayes, and he's a biologist. He's actually a teacher at UC Berkeley, and he studied environmental biology, and he discovered that the herbicide atrazine is an endocrine disruptor. He has lots and lots of papers. I actually wrote a presentation on atrazine too, so I can go on and on about this. But he has lots and lots of articles, and he proves himself by using the scientific method. He doesn't say, well, atrazine is an endocrine disruptor. He uses the scientific method to prove why. And fun fact about him, he is actually the reason one of my graduate teachers went into biology. She saw Dr. Hayes in the 80s, I guess, and was like, I want to be just like him. The next is Dr. Wang Stahl. She is a molecular biologist and a virologist. She studies viruses. And she cloned HIV, but she used the scientific method to be able to do this, to figure out the functions of the genes. The next is Dr. Lopez Chartillon. I think I'm saying the name wrong. She is also a virologist, and she studied rotaviruses, which are a really, really, really infectious virus. And again, she used the scientific method in her research. So, all 4 of these scientists use the scientific method. These are present-day scientists or modern scientists, and they all used it because people were trying to disprove them and say, oh no, you're wrong. So they use the scientific method, and they're like, hey, here's my research, here's exactly what I did, you try to prove it wrong. Because a lot of science is not only writing it down, but it's trying to prove other people wrong and modifying it based on things if it's proven wrong. So, scientific method versus logic. This dude, Lamarck, noticed that blacksmiths and their sons both had strong arms. So he thinks that, or he thought that being strong was passed on to their sons. Well, he's wrong. The sons were strong because they were blacksmiths too, and they were all using the hammer at the forge at a very young age. So we don't use logic. Instead, we gather evidence through observations and draw conclusions based on those. Then we rinse and repeat. We try to duplicate those responses. And the others are going to try to duplicate it and actually try to prove it wrong or right. One of my graduate school lab mates was given a project for an entire summer to actually try to prove this one paper wrong, and she finally did, but it took her all summer to prove it wrong. So the scientific method explains the world around us, or we use it to explain the world around us. It is our best guess. I'm going to have you start with a hypothesis. That hypothesis can be completely wrong. And we try to prove our hypothesis is correct. And then we repeat, and then we repeat. And if it's repeated enough times with the same results, it can become a theory. But you can't just do it one time and say this is a theory. That is not a theory. We'll discuss what a theory is later on in the conclusion section. Basically, a hypothesis is your best guess, and you try to test it repeatedly under different situations to see, does it hold true or not? Step 1, observe things around you. So we talked about those famous scientists. They observe the world around them. They try to prove things. Then you form a hypothesis. It's your educated guess as to why. My hypothesis for what we're doing is actually going to be a little bit on the silly side because I'm in a silly mood and I don't want you to make your hypothesis based on mine. Then we observe. We are going to watch several videos. These videos were made in the early 2000s when an 8 megapixel camera was an extremely expensive camera. And this fence no longer exists, this barbecue doesn't exist, and this fish tank doesn't exist, and the video can not only drive, but it can vote. So we're going to form a hypothesis. What do you think is going to happen to these cans when placed in water? Are they going to sink? Are they going to float? Something else going to happen? Then we're going to modify our hypotheses. We're going to design something. I designed it for you. And we're only going to test one thing at a time. So the first time around, we're only going to be testing one type of drink. And we're going to test it several times. I'm not just going to put one can in. I'm going to put 6. Then we're going to modify it. Instead of Minute Maid, we're going to use Diet Dr. Pepper. Again, 6 of them because we need a large sample size. And we'll see, does it stay the same or is something different? And we'll repeat one more time just for the sake of having a large sample size. But I expect you to change your hypothesis based on new information. And we're going to analyze. How many of the cans sank? How many of them floated? Why did they sink and float? And we're going to then write a conclusion. Did the test support or disprove? How does it change it? What would your new hypothesis be? And I'm going to actually make you look up what the right answer is supposed to be. Do not do that until you do the conclusion, though. And you're going to tell me why your hypothesis was right or wrong based on what you looked up. So I'm going to have further instructions on the problem and hypothesis and the forming the conclusion. But for now, start by the problems and hypothesis, work your way through these, and like I said, we're going to repeat it 3 times. I'm hoping that your hypothesis changes between the 3 times. Might not. And then you're going to form a conclusion. Thank you.